Through Jesus Christ we pray. Amen. Yeah. All right. So today this is actually our first workshop, artificial intelligence workshop for 2023, and I hope that you all will get an opportunity to integrate AI solutions in your future projects, and hopefully you get an opportunity to enter into a competition that's going to be held later on this year. So we're going to give you some more information on the competition at the end of the presentation. All right. Now, our objective, I'm hoping you guys can all see my screen. So this is essentially what we are here about. We're here about building and marketing each and every one of our skills. So this is an opportunity for us to learn and grow and share knowledge with each other, regardless of where you're from. And we want to, give a special shout out to our friends from Barbados. And the last activity we actually did, we had some participants from St. Lucia. They were advertising some positions available to join to work for their company. So for those who miss it, you missed a really good presentation, and I believe their positions are still open. So you can always check out the YouTube channel for all the past videos that we have done, and apply for that job position as soon as possible, if it is that you're interested in working for some companies within the Caribbean space, within the area of computer science. So we generally share our knowledge, we generally share our skills to hopefully help each and every one of us to grow and be game changers in the environment in which you work. So it doesn't matter if you're in agriculture, as we'll see here, you can use computer science, you can use information technology skills to better able to make life easier, to make the work that you're doing much more great. All right. So the problem that we're facing, and we're all from the Caribbean, and we realize there's a problem going on. Now there are companies that are not able to find developers. There are some skills and expertise that some developers may not necessarily have. So for those of us who don't know anything about AI, or they're just interested, or even if they have skills already in AI, this workshop will definitely help you to improve your skills and hopefully bring about some awareness about some of the different opportunities that are available and how you can integrate this solution within your space. All right. So we have a problem. We're all problem solvers. Let's go on and solve the problems. All right. Hi, good evening. Good evening, everyone. Thank you so much for joining. All right. So I'm hoping you guys are all up to speed with what's happening so far, and we'll be going right into our agenda. So I'll be introducing the speaker, and following which he'll be doing his presentation. And I believe he's going to be sharing an endpoint to give us an opportunity for us to play with some of the AI technology that he has. So, and of course, we'll have the discussion at the end, in case you have any questions, and we'd also give you some more detail about the competition that is coming up this year. All right. And of course, we'll just wrap up, giving you some information on how to get in contact with us. If it is that you'd have some skills that you want to share, whether it is that there is an opportunity for, if it is that you're a business owner and you would like to share, use this platform as an opportunity to share a job opening with the community, we definitely welcome that, of course. All right. So, Jordan Madden. Jordan Madden is a university graduate who is currently pursuing a master's in computer engineering. Now, prior to his graduate studies, he worked as a wireless network engineer at Huawei after earning his Bachelor's of Science in Electronics. All right. So he's very knowledgeable, and we're seeing that he's making a lot of waves within the technological space. So I hope you guys are ready, because we're going to, of course, have a great session with Jordan Madden. Jordan, over to you.
Hi, everyone, and thanks, Alvin, for the kind introduction. So today I want to present to you guys on the general topic of using AI to classify and detect diseases in plant leaves. So before I start the presentation, I want to kind of give you guys a demo of like show you guys what we're eventually going to build. So let me share my screen. And let me know when you can see it, please.
All right, so I'm seeing clearly, Jordan.
All right, thanks. So yeah, so this is what we're eventually going to end up building. This is the endpoint. And so how it works is I click here to upload the image. It would take me to my file manager. And so I'd go select the image, upload it. You see it's a tomato with early blight disease. So when I click submit, it passes it through the model and returns the model's classification output to us. And so let me just do it with a few other things. Let's see. Let's try with bacterial spot. Right. So now that you know what we're going to build, I'm going to take you guys through our presentation and then walk you guys through the code that's used to build it. So, are you seeing the presentation? All right. So yeah, so as the title suggests, I'm using vision transformers to detect diseases in plant leaves and classify them. So first, I'm going to talk about why I'm doing this, then gives you some technical background about like what transformers are, how some core transformer components work, like attention, and how transformers more generally work. And then I'll walk you guys through the code. So the point of the hackathon, as far as I understood, was to develop AI solutions for the Jamaican context, right? And agriculture generally is one of the largest sources of employment in Jamaica, but it's one of the least technically advanced industries. And like there are a lot of companies like series that are trying to revolutionize like agriculture, like with robotics and things like that. So that's kind of where I got the idea for this. So one thing, I was speaking to one of my friends who gardens and does some farming, and he was saying that one of the problems that he was having was that like sometimes these plants would grow, but then they'd catch diseases. So the yield of a lot of farmers is often affected by the diseases. So then I thought, okay, how can AI be used to help solve this problem? And well, not solve it directly, but like give you some way to know, like, okay, this is the disease that the plant has. And now this is like a treatment plan that you can use to cure the plant, essentially. So now some technical background. So what are transformers? So if you've heard of ChatGPT, transformers are the type of model that powers it. So it was an architecture introduced in 2017 in a paper by Google called Attention is All You Need. It's probably the most commonly used machine learning architecture now. So most things, like most machine learning solutions that you'll see now are probably built with transformers. And then, so they're kind of unique because they don't use any convolutions or recurrence as in CNNs or RNNs, but they're only made up of attention maps and MLPs, which are multi-layer perceptrons. But so talking about how they work, so the transformers need inputs to be sequences. They're a type of sequence model. So trying to think about how you can classify image classification as a sequence modeling problem. you have to break the images into chunks and then feed those chunks into the model sequentially, essentially. So as you can see, like in this image here, like you'll see the image is broken up into 9 chunks, and then they're flattened and fed into the model. But the model doesn't know which part of the image is which. So it has to be encoded with some location information that you can see here, like the extra learnable class embeddings. It gives you, like it tells the model that, okay, the chunk in position 0 is at the top right, chunk in position 1 is at the top of in the middle, the chunk in position 2 is the top left. And then the model just learns representations of the data internally and makes predictions based off of that. And this turns out to work really well. So like attention is one of the core building blocks of transformers. So how that works, how attention works is like the transformer is a sequence model, as I said before. So the elements in a sequence are relevant in context of the sequence. So they don't really have any meaning, like if you take them in isolation. So what attention does is it gives the model the ability to learn what elements in the sequence are relevant to the current element that you're focusing on. So for example, in the context of an image, if you have a picture of a person, right, and the model is looking at their face, then the pixels representing the body of the person would be more relevant to the face than the pixels in the background. So that's kind of what attention enables the model to learn, right? So now I'll walk you guys through some of the code, that I used to develop the application that I showed you earlier. Are you seeing the screen?
No, it's coming up. Okay, great.
Okay, yeah. So in case anybody wanted to play around with the code or anything like that, I did it in a notebook in the form of like a blog post almost, quote unquote. So like it gives you like an introduction and it walks you through what I did with the code at along each step of the way, right? And I ran this pretty recently so that I could show you guys the demo. But when you're running it, you can expect it to take between 1.5 hours to 2 hours to complete training and all of that. So yeah, so the first thing that I did is install all the libraries that we're going to need. So this environment is called Google Colab. It gives you a Jupyter notebook environment through which you can access GPUs. GPUs are important for machine learning because you need really powerful compute that can run the models in parallel, and GPUs provide that. So, so these are the libraries that I ended up using through the rest of the code. So the first thing that you had to do is connect to Google Drive because you need some cloud storage to hold the data set. You could upload the data set directly to Google Colab, but that's really slow. And like I had a lot of problems when I was trying to do it that way. So all of these 3 blocks of code are just dedicated directly to loading the data into Google Drive. And here is where the code that I used to pull the data from Google Drive into the local memory. So I loop over all the data, create directories in Google Colab, and store the data there. Now, then after that, you split the data into your training and your testing sets. I used a testing size of 20%. So 80% of the data was used for training and 20% was used for testing. So there are 38 classes of images in the data set, and I use 100 images from each class, because Google Colab, although it's really powerful, it's really limited. So it's powerful, but it's limited. So it's limited in terms of like the memory that you can use and the amount of time that you'd be able to run the models for. So to save on memory, I only used 100 images from each of the 38 classes. So I ended up with a data set of 3,800 images. And of those 3,800, I used 80% for training and 20% for testing. And here, you can kind of just visualize some of the images in the data set. So you see you have healthy strawberries, healthy grapes, the strawberry with scorch, another image of healthy strawberries, some the peach leaves that are healthy, and just a few other things. And I did this just so that I could get an idea of the data that I was working with. So now with transformers, like I said, you have to do a lot of pre-processing before you feed the image into the model, because the model doesn't understand what images are themselves. So the preprocessor is what is used to do all of the pre-processing, like splitting the image, like chunking the image, and all of those things that I mentioned before. And here I had to build a data set that I could use to take the data from the training and the testing split that we had generated earlier and pass it into the model in the batches. So this is what I used to do that. This data collator, what it does is it helps with the batching of the operations. So it takes the data from the data sets in batches and feeds it directly into the model during training. So now, here's where I loaded the actual transformer model. So as you can see, I use the library called Transformers by Hugging Face. And what they do is they give you, somebody said something? Okay, yeah. So what they do is they give you a framework generally that you can use to pull models from their centralized storage and fine tune them from there. So that's what I'm doing. I'm using a pre-trained model from their central storage. And so I loaded that into memory here. And here is where I actually did the training of the model. So I specified the hyperparameters like the learning rate, the batch sizes, the number of epochs that I was going to train for, the number of logging steps that it needs. And then I trained the model. I passed all of that into the trainer and trained the model. As you can see, the model was training for 34 epochs, well, 35, because it started from 0. It's training for 35 epochs, sorry. And here you can see the loss of the model decreasing as training was going on. So the loss, that's important because the loss kind of indicates how well the model is performing. So the lower it is, the better. So if it started higher, but ends up going lower during the course of training, that means that your model is learning good representations of the data. And it's learning to classify the data correctly. So I made a prediction function that takes the image as input, does some pre-processing to it, and passes it into the model, and then returns the output class of the data. And like from the training that I did, we got the model to 83% accuracy. Now, we didn't use a lot of data, and I didn't train it for very long. I only trained it for 35 epochs, and there were only 3,800 out of 50,000 images that I used. So I didn't expect the model to perform very well, but it did better than I thought with 83. But usually, like, you don't want to deploy something into the wild if it's like 83%, because if it's taking like hundreds of thousands of requests, that means that it's going to fail like every 17 out of 100 times. And the Gradio is what I actually use to build the API. And Gradio provides like an interface that you can use to build interfaces, and it lets you host them online so that other people can use them. So it gave me this link, which is what I had used up here. And that's how I showed you guys the demo earlier. So if I open this link, hold on. If I open this link, yeah, there we go. If I open this link, then it will take you to this website, to this endpoint that it generated itself, that lets you upload the images and pass them. It will pass the images through the model, and then it will give you the results. So for those that weren't here earlier, when I actually did the demo, I'll just do it again. So upload the images, and it will take me to my folder, my file manager. So I collected some data that wasn't in the training or the testing set. And so I'm just going to pass it through the model. So this is a tomato leaf with bacterial spot. So passing it through the model, if I submit it, it tells me that it's tomato with bacterial spot. If I do it again with something else, tomato with blight, and submit it, it shows you that it's a tomato leaf with blight. If I do it again with something else, soybean, let's try that. It's healthy, so this should tell us that it's a healthy soybean leaf. Yeah. And yeah, so that was essentially how I just kind of walked you guys through the process of how I built that. And if you guys want, I can send you guys the link to the notebook if you ever need it, if you need it. And I'm open for questions.
Okay, thank you very much, Jordan. So yes, you can go ahead and share the link in the chat, and we'll of course share it with our group, the entire community. Let me just bring up my page. Okay, so we're just gonna go get a couple questions. So for all those who didn't catch everything from the start, essentially we would have gone through the presentation with Jordan Madden on his AI development. So he has created a tool that allows the machine to collect an image, read this image, understand this image, and essentially make some prediction as it relates to what is happening to the leaf. So in the last part, we saw where he was able to upload a leaf, and the computer actually understood that this leaf was healthy. So we can actually see where AI and this specific branch of AI where it's learning how to understand images, how to understand, patterns and so on. We can definitely see where this is applicable in a lot of areas of society, whether it is in the banking world to see images for the fake IDs and recognize that these IDs are fake, or whether it is even in agriculture to see where some plants may be exposed to a particular disease, and we can easily identify that. All right, so as I said, feel free to post your questions in the chat. Any questions from your side, Ashane, from YouTube?
Let me check. No, but let me ask a question. All right, when it come on to image quality, like for example, I've worked with image classification and recognition when come on to driver's license and so forth. One of the major problems that we tend to face is, poor quality of images. How does the AI tend to under those scenarios? Not to mention, like, for example, lighting conditions, glare, and so forth. do some form of image optimization, then do the classification. How does it handle that?
Yeah, so there are a number of ways you could tackle that. You could optimize the images, like you could process the images before you fed them into the model. To like you could use image processing techniques like edge detection, for example, to try sharpen the images, and or you could just get around it with more data. Like the models will like models learn from data. So if you feed more data into the model, more good data, I should say, then the model will learn better. But yeah, so those are kind of two ways that you can get around that problem of poor image quality. But yeah.
No. Okay. I think someone has how easy would it be? How easy would it be to have this implemented in an app? You want to answer that, or should I touch on it?
Yeah, you can if you want to. I'm not too familiar with app development, so you might be
Well,
suited.
all right, noted. So, given what he had showed in the sense that what you do is upload that image, and from the upload, once the image has been uploaded, it will run the classification and optimization of that image. So where I'm getting at is that it will somewhat be easy to build it out in a mobile app, because one, all you need to do is have an API for like that AI solution to send the image to that API, and then that API would, utilize the AI to do the classification and so forth. Of course, you know that, for example, it will take some time to the processing to be over, maybe couple of minutes, whatever, but either a user can get notified by email, telegram, whatever, or you do like a constant polling to check if, as this image finished processed. Once the image finished processed, you pretty much send back the result to the mobile app, whether through a push notification, WebSocket, or just checking a different endpoint that will have the result. So it's pretty much like easy, but it's depending on the approach you want to take it. But regardless of what anything, you need a backend server to process that image upload and send it off to the AI solution, and of course listen out for the completion of the image processing. And of course, you can build this in Flutter, React Natives, or just native Android or iOS uh, software development. Okay.
So just not to cut you, Roshin. All right. So if we recall, one of the things that you would have said was that the image, it would have been easier to upload the image to the cloud. So essentially, there are cloud providers there. Once you've uploaded the image, you definitely want something to be able to break down the image into smaller pieces so that the software can identify the different parts of the image to separate the background from the actual image. So that was actually a very important analogy that he gave earlier when he was talking about facial recognition, that you'd want to the application to be trained to recognize the person's face different from the background. So essentially, training your model is going to be very important. But generally speaking, this is a easy solution for us to develop, as long as we stay focused and bring all of the different areas of computing together, because the whole concept of breaking down a problem into smaller pieces, that's a very important concept here, as we can see where the image is actually broken down to understand each pixel, what is located in that frame, etc., etc. All right. So let's see. We have someone saying that yes, this would be very interesting because you'd be able to integrate it with robotics. that would be able to work on a farm, in a farm situation, and be able to autonomously recognize the difference between the ground and the air. Is that what I'm understanding from this question or this comment? But yeah, essentially training is going to be important because the model wouldn't have understood what the different images are. All right, let's move on to the next question or comment. All right, from Stedman. Can transformer-based models perform segmentation as well?
Oh yeah, definitely they can. So anything that you could do with like a convolutional neural network, you can do with a transformer. You just have to frame the problem differently. So while with a CNN, you could just feed the image to the model directly. With a transformer, you do have to break up the model into the chunks before you feed it. You have to break up the image into chunks before you feed it into the model, for example. But like with the technology, like with the libraries that I was using, that functionality is kind of abstracted away from you. So you don't really have to worry about that. So you can just input the image into the model directly, and all of that will be handled for you.
Okay, great. Okay, so I guess we got some clarity now. And apparently we'd see where this solution would be able to recognize healthy and unhealthy plants from the ground as well as from the air. I think that was really what Jelani was trying to communicate. So yes, as long as the image is essentially being captured, ground or air, picture quality, as Shane would have spoken about earlier, that would definitely play a factor. All right, let's move on to the next question. All right, when it comes to position encoding, is the image pixel chunks being treated as a vector representing a one-dimensional string, or is this a way to represent their 2D coordinates, since two pictures are inherently 2D? Okay, let me see if I can understand what this person is asking. So when
I think I get it.
You got it? Okay.
Yeah. That's a bit more technical than I wanted to get here. But essentially when you're with the positional encoding, the positions are given to each chunk with sine and cosine vectors, right? And so the model will learn that, okay, this chunk belongs to the top left, the other chunk belongs to the top right, etc., etc. Like the model does all of that internally, like during training. So it understands that because the positions are constant across images, like the first position is always going to be the top left, the second position is always going to be the top middle, for example. The model learns that it learns how to piece the image back together internally, if that makes sense.
Well, it makes sense to me. I hope that's clear to you. Oops.
Yes, it is.
Clear.
Thanks for that.
Any questions from YouTube, Oshie?
No.
Okay. All righty. So.
Oh, I think he has a follow-up question. I don't know if how are they tokenized? Oh, I think that was answered as well.
Right. Okay. So as I would have said initially when we started, that this is actually the first. This is one of our first the first AI workshop for 2023. And we are actually going to be having several more workshops on AI and AI-based tools, AI-based solutions in preparation for a big event coming up in tentatively September 23rd. So we have one of the organizers online, Matthew. Do you want to tell us a little bit more about the hackathon that will be held in September? DV? Okay, so we're not hearing from Matthew just now, but essentially, I'd want each and every one of you guys, especially if it is that this is something that you're interested in terms of building your skills, having an opportunity to compete with bright minds within the university and outside, because the hackathon is actually going to be open to not just university participants, but as long as you're technologically inclined and you can build a hackathon, you can participate in this hackathon. We're definitely going to be encouraging you to join. So more details will be published as it is made available. But this is an opportunity for you guys to, come to these workshops, strengthen your knowledge base, and essentially prepare for hopefully what's going to be an exciting event at UA coming in September, DV. So let me also add that there are going to be prizes and, hello? So there are going to be prizes, and I definitely would want us to see where AI could actually make whatever situation that we are in, whatever solution that we're building, if it's possible, where we could integrate AI to simply, make the work a little easier. Because if it is that we're going to be building a solution where we're going to be manually capturing, what some data that someone has entered, and then make a prediction based on that data. If we're going to be hard coding that with some for loops and so on, that may not necessarily be so efficient. But if it is that we can, create a solution that incorporates, AI, where it can learn and make better predictions than from what we can code with if statements, this would definitely be an opportunity for us to learn some new skills or even improve on the skills that we have. So as I said, look out for further details as it's made available. We'll definitely publish the information as it relates to how to enter, the date of the event, and from what we understand, the venue is actually going to be UA. All right. Now we're going to be wrapping up unless there are any questions around the presentation that was just held, but we definitely want to thank Jason Madden for giving us an insight and as to one of the tools that we could use and how it is used to essentially for a computer now to be able to see. Because essentially the computer is mimicking human behavior. It's seeing a leaf and now saying, this leaf is healthy, or this leaf has insects, and so we're able to advance in terms of how we meet the needs of our farmers. All right. So for those persons,
if I could say one thing before you leave.
Sure. Oh, Matthew.
Yeah.
Great.
Yeah, I just want to thank Jordan for that very informed presentation. I also want to thank everybody that came. I mean, this is a very big first step in our mission to really expose the talent that we have here in Jamaica for AI. I mean, right now it's really the right time to get into the AI field, and I think these workshops are very important because it can at least ease people that may have some fears about getting into the field. This can be a vehicle to ease them into the field. So I'm really encouraged by the people that came today, and I hope going forward we'll have even more people tuning into these very informed presentations. But yeah, thank you again, Jordan. Thank you to everybody that came on.
And thank you, Matthew, for allowing us to be a part of this event, because this UE AI hackathon is actually a part of the 75th anniversary of that UE is celebrating. And this is essentially just an opportunity for us to each, enter as you said, and show your talent and, become more familiar with AI, right? So if it is that you would like to reach out to us, if it is that you'd like to send us an email, if it is that you have, come on late, but unfortunately you recognize that, hey, this is a very important event that we just had, or some of our past events, or perhaps you just want to brush up on some of those skills that we may have already reintroduced to you, because we're all IT professionals. You have an opportunity to, of course, check us out, send us an email, be a part of the group, because we definitely would want to ensure that each person grow their individual talent, as of course, for all of us to come together to make a big impact on the world, whether it is that we're from St. Lucia, from Barbados, from Jamaica. We're all a part of the Caribbean, and we can change the Caribbean from being a consumer of technology to a producer of technology, simply by each and every one of us coming together to build our skills, to grow, to make a difference. Even help out our farmers, with whichever area it is that we see where technology can make a difference. We could definitely grow together. All right. So with that being said, we are going to end here. But of course, next week we'll be having our next presenter. And I hope that you guys are definitely seeing where you can integrate, as I said, your AI solutions to fix some of those problems that you've been having for a while now. All right. Oh, and we want to give a quick shout out to the Jamaican Artificial Intelligence Association, OSUB Limited, Jamaican Developers Community, and you can follow the Jamaica Artificial Intelligence Association on social media, and JAIA_876. Right, so exciting times ahead. As I said, if it is that you already have your teams ready, from what I understand, the maximum team size is either 4 or 5, but it's not a one-man show. So get your teams ready and look out for the UE AI hackathon coming up in September. All right, have a great evening, everyone. Blessings.